Hi everyone. On Monday, I know I threw solving equations at you. It kind of fell out of nowhere. And for today, I do want us to just put that on the back burner. We are going to revisit it, but I don't want us to worry about it too much today. There is something else that we want to cover before we dive into the world of solving. So, before we get into today's lesson, go ahead and try out today's warm up where we are subtracting polynomials, okay? And I'll meet you back here with the answers. All right, and here's the solution for number one. I'll show you how we get the solution for number two. You can skip ahead if you don't need to see this. But with 15x squared minus 12 minus 3x squared plus 6x plus 4, 15x squared minus 3x squared gives us 12x squared. 0, right? Nothing minus 6x will give us negative or minus 6x. And negative 12 minus 4 gives us negative 16. Okay. So the final solutions are right here. Okay. It's going to be important for us to understand subtraction specifically for today's lesson. So with the FLT, given a quotient or rational expression, we will be able to know how and when to apply long division or synthetic division. Okay, so there's two methods of division that we can cover with polynomials. And the first one that we're looking at is long division. Okay, if you think about long division with numbers, it's very, very similar to that process. And it also includes similar vocabulary. So when we look at these vocab words here, okay, it's important for us to know what we're talking about when it comes to division. So with a dividend, this is the value being divided Okay, the divisor is the value that divides the dividend. Okay, the quotient is the result when dividing, and the remainder is what's left over after dividing. Okay. So let's look at a basic example here and we can identify all of these parts in a long division problem. Okay, so let's look at a really basic example here. Let's try 7 divided by 3. Okay. So in this example, 7 is the number that's being divided. So this is the dividend. And 3 is our divisor. Okay. So we would read this as 7 divided by 3. And when we solve this through, we ask ourselves, how many times does 3 go into 7 evenly? So you probably know, okay, 3 goes into 7 2 times evenly, right? So that 2 goes on top. And when we solve through, we take that 2 and multiply it to 3, and we write that underneath our division problem. So 2 times 3 is 6, which goes here. After that, we subtract. And 7 minus 6 gives us 1. Okay. So when we write this result, we get 2 with a remainder of 1. Okay. Now, when we say the actual answer for this problem, we say that 7 divided by 3, that's actually equal to our quotient 2 plus our remainder 1 over 3, or 2 and 1/3. Okay. So the way we write this answer and the way we set up this problem and solve through, it's very, very similar to how we do it with polynomials. Okay. And note here that when we write the final answer, we write it with the quotient plus the remainder over the divisor. Right, with the divisor being the value on the outside of our symbol. Okay. We want to be mindful of this as we solve and divide using polynomials. Okay, our answer will look exactly the same. All right. So let's take a look at a few examples here. Okay, so for these examples, you always want to make sure we are working with polynomials in standard form. Okay, organizing it is going to be really important here with long division. When you get to delta math, the directions will say use long division to find the result. If there is a remainder, express the result in the form of q of x plus r of x over b of x. Okay, this just means rewrite it similar to how we wrote it above. The quotient plus the remainder over the divisor, which is that number on the left, or polynomial on the left. Polynomial division does work for all types of polynomial quotients, so it is going to be important to note that moving forward. Okay, for number 1, we have 3x cubed plus 5x squared plus 8x plus 7 divided by 3x plus 2. So just as a note, this is our divisor. Okay, when we set this problem up, we have our division symbol here. Okay, this one is different from this symbol. Okay, this is a square root, but the division symbol is just a door. There's no hook on it. So don't make that mistake. All right. So the dividend goes inside. And then the divisor will go to the left, 3x plus 2. Okay. Now with long division, it's really important that we organize our work and we write clearly. There is a bit of room for error here, so you want to be careful with your work. All right. Now when you start, you always compare the term with the highest degree in your divisor to the term with the highest degree in your dividend. So in here, we're going to compare 3x to 3x cubed. And we're trying to think, 3x times what gives us 3x cubed. Okay. Here, if we multiply 3x by x squared, that will give us the 3x cubed. So the x squared will be written above the x squared term on our quotient line. Okay. Next, we're going to take x squared and multiply it to each term and rewrite it underneath our dividend. Okay, so x squared times 3x is 3x cubed. And x squared times 2 is 2x squared. Okay. Next, we're going to subtract this from the terms above. So 3x cubed minus 3x cubed, this will go away. And 5x squared minus 2x will give us 3x squared. Now, we're going to take this 8x, drop it down, and rewrite it next to 3x squared. And we start the process over again. Okay? Notice that since our divisor has 2 terms, we're only going to work with 2 terms at a time. Now we're going to compare 3x to 3x squared. 3x times x gives us 3x squared. So that x will go right here and multiply that x to each term in our divisor. X times 3x is 3x squared. X times 2 is 2x. Okay. Once we get that subtracted off, so 3x squared minus 3x squared will go away. 8x minus 2x gives us 6x. We're almost there. We have this leftover 7. So we'll drop it down. And figure out this last part of our quotient. Okay, 3x times what gives us 6x? That'll be 3x times 2. So 2 times 3x will equal to 6x. 2 times 2 is 4. All right, subtract that off. 6x minus 6x will go away. 7 minus 4 gives us a leftover of 3. Sorry, it's really wonky. Whew. All right. So all that's left for us to do at this point is rewrite our expression, our quotient and remainder. So this will be written as the quotient plus the remainder over the divisor. In this case, it's 3x plus 2. So our quotient is x squared plus x plus 2 plus the remainder 3 over the divisor 3x plus 2. And this is our final answer. Okay. Yeah, we did it. All right, number 2 is a special type of problem. Notice here that we have what you might call a missing term. Okay, if you look at 6x cubed plus 10x squared plus 8, we are missing an x term. Same thing with 2x squared plus 1. We are also missing an x term there. So we have a missing term. And whenever we see that, if we see a gap, you want to include a placeholder. Okay, so let's look at how we set this up. All right, so we're going to copy this down. 6x cubed plus 10x squared. And we're going to include a placeholder here, 0x plus 8. Okay, we have to include that placeholder. It's super important when we work with any type of division, whether it's long division or synthetic. Okay, so that's how we write the dividend. Now our divisor, 2x squared plus 1, will look like this, 2x squared plus 0x plus 1. Okay, so we have our placeholders in our problem. Now we can divide as normal. So compare 2x squared to the highest degree in our right side. So the highest degree on the left compared to the highest degree on our right. Okay, 2x squared times what gives us 6x cubed? Okay, that will be 3x. So our 3x gets placed above our x term. Now we're going to take 3x and multiply it to every term in our divisor. So 3x times 2x squared is 6x cubed. That's written underneath. Three x times 0x is just 0x squared. 3x times 1 is 3x. Okay. For the next step, we are going to subtract each term from the dividend above. Okay. So 6x cubed minus 6x cubed, that goes away. 10x squared minus 0x squared becomes 10x squared. And 0x minus 3x is negative 3x. Then we're going to take this plus 8 and drop it down. Okay, so next line, again, we're going to compare 2x squared to this line here. So 2x squared times 5 gives us 10x squared. So that 5 will go above in our quotient line, and we'll take 5 and multiply it out and write it underneath. So 5 times 2x squared is 10x squared. 5 times 0x is just 0x. And 5 times 1 is 5. All right, so we will subtract it off from the terms above. 10x squared minus 10x squared goes away. Negative 3x minus 0 is just 3x. Sorry, negative 3x. And 8 minus 5 gives us positive 3. And we are almost done. Okay. So we have our quotient, we have our remainder, and we have our divisor. So when we write our answer, it's the quotient plus the remainder over the divisor here. So our final answer will look like 3x plus 5 plus negative 3x plus 3 all over 2x squared plus 1. Okay. So when you're solving these problems, there are a few things to note. The first is if you have a gap, you have to use a placeholder, whether it's a missing x term, a missing x squared, or a missing constant. You always want to make sure there's a placeholder. The next thing to take note of is be careful of those dang signs. Whenever you subtract that polynomial off, you're switching those signs and doing the opposite. Okay? But once you double check your work and once you practice this more, you'll start to get the hang of it. You got this.